When we walk into a modern airport, we see millions of square feet of rigid glass and steel. But in reality, these massive structures are in constant motion, stretching, compressing, and twisting as they react to their environment. The concrete slabs are under relentless daily stress. Sunlight causes severe thermal expansion. High winds induce structural sway, and foundations settle unevenly. If an airport was built as a single solid piece, these forces would tear the building apart. To prevent structural failure, engineers slice the concourse into separate, independent slabs, leaving deliberate voids between them to absorb the movement. How a facility manages these invisible fractures determines whether it can endure its own physical environment over the long term. A raw, open gap in the floor presents a severe set of vulnerabilities. It is an immediate trip hazard for passengers, a weak point for the concrete edges, and an open corridor for water to flood the lower levels. In an aviation environment, a single snagged luggage trolley or a halted line of travelers at a broken floor joint creates a bottleneck that cascades into terminal-wide delays. Dseal airport expansion joint systems act as engineered bridges. They span these structural voids and absorb extreme multidirectional movement while remaining entirely hidden in plain sight. Looking at this system profile, we see the mechanics of the dual seal design. A flexible V-shaped rubber gasket locking securely into the heavy extruded aluminum frames, maintaining a watertight barrier that flexes dynamically as the concrete slabs shift. The system absorbs relentless physical trauma from the building, yet the passenger rolling their suitcase overhead feels absolutely nothing. The structural demands escalate at the building's exterior. Parking decks and access roads expose these joints to direct weather and extreme repetitive impact from multi-ton vehicles. This chart shows the immense scale of those requirements. Standard pedestrian joints handle light pressure, but exterior transport zones require Group G load capacities, engineered to support up to 160 kilonewtons, or roughly 15.7 tons, of heavy multi-axle traffic. To withstand that crushing force, Dseal's heavy-duty exterior systems are permanently locked into the deck. Thick metal bases anchor directly into reinforced concrete, transferring vehicular loads evenly across the substructure. On the surface, the thick ribbed EPDM membrane repels water and prevents debris from jamming the void. This specific formulation provides outstanding weather resistance, enduring high UV exposure, ozone, and extreme temperature swings without degrading. Securing these exterior gaps serves as the first line of defense, preventing water and structural decay from creeping inward toward the airport's core. Moving inside to the high-density concourse floors, the engineering priority shifts. The objective is no longer about resisting multi-ton vehicles. A perfectly flat surface is mandatory. Interlocking aluminum plates provide a flush finish, ensuring carts and footsteps pass without catching. Notice the hidden structure. The blockout design seats perforated frames deep into the recessed concrete, leaving a narrow sightline for premium architectural finishes. Even these perfectly aligned interior floors face a catastrophic threat from earthquakes, which violently shift the rigid concrete slabs in multiple directions at once. Inside is a specialized mechanical defense. When a seismic shock hits, a hidden centering bar and compression spring assembly immediately react to the lateral stress. Rather than buckling under the pressure, the system utilizes a pop-up design. The cover safely disengages during the violent movement. Once the earthquake subsides, gravity and the internal springs automatically return the slide plate to its original, aligned position. Maintaining interior integrity during a disaster requires hardware that physically adapts to the chaos and resets itself completely. These structural gaps do not stop at the floor. They travel vertically up the interior walls, across the ceiling grid, and over the roof. For vertical surfaces, engineers deploy glide plate systems. The metal wall covers utilize a snap-fit design, securing the plates tightly into the frame clips. This allows the walls to shift independently while keeping all mounting fasteners completely hidden. High above, roof expansion covers seal the building envelope. These systems utilize gasketed fasteners and fit neoprene weather washers to compress tightly against the frames, forming an impenetrable barrier against wind-driven rain and air pressure. Inside these massive voids lies one final defense mechanism. Left untreated, a vertical expansion gap acts like a chimney, rapidly drawing smoke and fire through a building. To prevent this, an ASTM E119 certified fire barrier is anchored directly into the concrete opening. This barrier is constructed from a flexible, high-purity ceramic fiber blanket and stainless steel foil. It moves dynamically with the building's sway, while providing up to 2 hours of certified resistance against intense flames and toxic smoke. The entire facility operates as a single, sealed unit. A failure anywhere along the building envelope compromises the safety of the entire structure. The ability to sustain a structure of this magnitude relies on the microscopic properties of the materials holding it together. The extruded frames forming the backbone of these joint systems are forged from premium 6063 T6 aluminum alloy. This specific temper provides a high yield strength, ensuring the rigid edges will not warp under constant friction and heavy loads. Before reaching the site, these components undergo rigorous quality assurance testing. Engineers verify strict dimensional accuracy and subject the materials to simulated load conditions, confirming they will perform predictably for decades. Developed by Mr. M.K. Dhawan and the engineering team at Dhawan Associates, the Dseal product line is rooted in precision Indian manufacturing. It brings decades of specialized expertise to massive infrastructure projects worldwide. You cannot build million-square-foot international hubs without absolute certainty in the physical metallurgy bridging the gaps. When we pull back and watch a modern airport operate at full capacity, we see thousands of flights and millions of passengers moving in a flawless, non-stop rhythm. The silent enabler of this massive economic engine lies right beneath their feet. Dseal systems take the relentless punishment of thermal shifts, settling earth, and rolling steel, neutralizing the stress before it ever reaches the surface. Dseal airport expansion joint systems are engineered for continuous movement and built specifically for the demands of critical infrastructure. True perfection in architecture is found in the world-class engineering that works so flawlessly it remains entirely unnoticed.